about extruding text. The question is there a sequence that is critical? By that I mean, do I need to complete sketch before extruding? My problem seems to be related to when I add bridges to the letters. I even experiment with letters that need no bridges. For example, I type XXX in a text box, no significance except the lack of needing a bridge, and it produces a complete project with only the last two of the X's showing. Alright, we're going to just go through adding some text to some flat planes in Fusion 360 here. It'll kind of cover all of this. Alright, yeah, we're all up to date. Perfect. We'll start by creating a sketch in the YX plane or XY plane. And, excuse me. Of course, as soon as I start talking on the mic, I get all choked up. I'm going to do a rectangle and then go over here into my sketch palette and use center rectangle just to create a box. I'm going to use some random numbers, 8 by 6. You can see my keystrokes are highlighted in the left hand side if you want to see some of the hotkeys I'm using. Under create, I'm going to go to text. I'm going to put that over top of this. And I can center that text. And we're going to go XXX. We're just going to use Arial. Let's make the text height a little bit bigger. And give it a little bit of spacing. Perfect. Okay, so there's a few different ways you can go about this, depending on whether you want to be modifying this or not. Let's do one method to start with, which would be right-clicking on here, explode text, and you can see they show up in green, which is locked sketch lines. We can unlock those lines by selecting all of them and using the fix unfix tool. Sometimes it doesn't do it the first round and you need to use that tool twice, and from here you can manipulate everything you would like if you want to, or it's created a solid profile that we can now hit E for extrude and extrude to the thickness of 14 gauge, and that works out for this font. The one disadvantage of doing it this way is that you can't change that font easily later, because if you go back and go to edit sketch, it's a shape now, it's not a font menu anymore. Alright, so, and let's say, I'm going to finish this sketch. Let's say one of these didn't show up for some reason. You can go back into your sketches here and you can either edit, or you don't need to edit it, but you can visually put it up so you can see it. And now you can go into extrude here at the top right, or you can hit E for extrude. And now, because that's at the bottom plane and the body is actually between you and that sketch, you can hold down left click for a second and it'll bring up every layer that's in between you and infinity. So there's the face, the profile, and the other face for the bottom side. So we want the profile, and now we can extrude that through in a number of different ways. But oops. All right, so another option we have here is we're going to go back in time here. Back to just being a sketch, and we can go or not a sketch, just being sketch text, we can extrude this body to the thickness of 14 gauge. We can look at that sketch again. Now we can hit extrude again, and again we can hold down left click and it brings up the option for sketch text. Alright, and under operation we're going to do a cut. Oops. Not two profiles, I just want the sketch text. Oh, come on. Anyways, I'm having a fight here with this now. Sketch text. Target body, no, target body found to intersect. I keep accidentally selecting the other one when I keep doing that. Anyway, sketch text. I don't know why it's going down, but we want to go up. There we go. Now, the advantage of doing it that way. Let's get this back up. The advantage of doing it that way is now we can go back to the sketch menu and we can double click this and it's still text. So we can now go through and let's say scroll to aerial round. Okay, we'll finish that sketch and it has updated this now to that aerial round. If I go back again, go to edit sketch, double click on this and switch it to whichever I feel like, even one of the stenciled ones. Let's say I know it's ironic to stencil the X, but so that's a huge advantage of doing it that way. You could go in here and you can change the height and it's still going to keep updating because it's text, not objects or sketch objects. Perfect, and we might as well just run through it from here. So let's say we now went to manufacturing. Going to make sure we're in the fabrication tab. We're going to start a new setup, and our setup is setting up our relationship between the material, which is the golden outline here, and the work being cut. Or I should say the work and the object being cut. So right now our home point for this, which is different from origin on the model, this is our origin in relationship to origin in between the machine and the work and this project. So usually for Langmuir we're in bottom left hand corner, and there's a few options under stock. Like right here I have an automatic offset from that corner of 1/4 inch, but you could set it right to 0 if you have some kind of indexing. That'd be fine. And this is where you can also add a name that'll come out in your G-code at the end without having to remember to re-enter it. So you could go font example here. Perfect. So now I have that in my setup. I can go up to the 2D profile, and this is where I'm going to be selecting cutting tools. I guess I could go through making one up. Let's go into our local library that's on our computer. And I have all sorts of different tools in here, but let's create one from scratch by using this plus icon. I'm going to go down here to cutting plasma. And there's only so many actual line items we need in here, but let's say it's a hypotherm 85. And actually I'll put it in front of here. We're agreeing to be using 45 amp standard consumables. Standard. I don't know what that means. And we really don't need all this stuff. You could put it all there if you're reordering from the same place or whatever. Okay, for nozzle diameter in the Langmuir instructions, they do say 1 inch, which is, I think it's basically talking about like the barrel from here to here on the torch. We don't want that because the simulation in Fusion 360 picks up on that for some reason since a update last year. So we're going to just put in whatever the kerf width is. So let's grab that manual. I happen to have that manual on my computer. Are you used to at one time? Ah, there it is. All right. So, let's get down to the cutting charts. And let's say we're cutting this out of, well, we already said it's 14 gauge, but let's find that here. And we'll set that up. All right. So these are our estimated kerf widths. We're going to use 45 amp. Let's say shielded consumables. I think that's what we wrote there. It is 0.055 is kerf width. And we'll actually just scroll down to the cut chart, which is right here for mild steel. And this is the line we'll be looking at here. We'll just refer back to that in a second. So 0.055, because we'll make that nozzle diameter the same as kerf width, 0.055. Holder, we'll just leave everything the way it is. Under here, we can put in our feed rate and some of our other recommended information. Let's take a look again. So it does show our work to torch distance or our cut height. It shows our pierce height here. Our pierce delay. There is a difference between, I think the XP is a little faster than latency wise than the Pro. So usually you start at 0.5 with the Pro. It says we can do 270 inches a minute and our voltage is 130 for that. So let's go back to Fusion. I'm going to put in our cut height, pierce height. These numbers actually don't move forward right now. You'll have to re-enter them at the end. But one day if they do, then you won't have to be messing around with your tools. And it's easy enough to just put in there. I'm just going to put 0.5. 85 psi of air. And this post processor is basically just the tool number, and we don't mess with any of this. And we're going to say accept. So there's our new tool. I actually got the feed rate wrong there, so I'm going to actually go back in there and edit it. Alright, so I'm going to cancel that because I'm actually editing the document version of that, which is attached to that setup. I'm going to go back and edit it in the library itself. I should put this at 270 while I was here. All right. Now I can simply click this face, the face contour, and it will know to select all the inside and outside without being on the wrong side. Now I like to always reduce the tolerance by 1, add some smoothing. We're not going to do any feed optimization right now, but that's where it adjusts the tool path feed rate to have the torch be able to get the finer details of corners and such. It shows an illustration of basically with milling, but it shows an illustration of kind of how it works. With this, we're not going to need it. So let's go to lead-in radius. Just put a small one on here. I'm just doing kind of a minimal lead in on these. All right, and this is preferred lead in position. So if you had a back part, if this was going to be a bottom that you weren't going to see, you could say, hey, I want the lead in to start there. Let's add feed rate optimization just to go through that. So this is like the maximum deviation angle. It will apply feed rate optimization to it. So obviously this is well over 25 degrees. So it would it would start slowing the torch down before it hit this corner. And how is the best to explain that? As the column of plasma is moving, or the arc is moving through the material, from where it enters the material at the top and where it exits the material at the bottom, there can be a little bit of lag there. The lower portion can be will always be at least under or trailing the upper position of where the torch is. So the idea of the feed rate optimization is it slows it down so the lower trailing edge of it can catch up, and it can be more perpendicular before making that more significant change in motion. So these are just some of the constraints for that. One is the maximum direction of change. One is the maximum reduced feed rate for this kind of radius. And then the distance, how much do we reduce that feed rate? So like the length before the cut, it starts reducing the feed rate. So the column of arc, or the plasma arc, can become more perpendicular before making that change. And then the amount of feed rate reduction you want, and typically it's about 60%. I wrote it because you can write formulas in these just like you can in Excel. So I have mine as cutting underscore feed cut, or tool underscore feed cutting times 0.06, so 60%. So it reduced it from 270 to 162 automatically. So if I made slight changes with the other one, it would update this one with that rule in mind. But you could write in a predetermined amount as well. Okay, so we'll move to linking. I think we went through all that. Let's process this. So it's made us a toolpath here. And then if we go and look at a toolpath, and I have no idea why, for some reason in my head, the beginning should be a green dot and the end should be a red dot, like start and stop, but it's not how it is in Fusion 360. It is red dot to start, because that's the way Fusion 360 likes to do it. So it's showing this green line to start with, which is the center of our cutting path. This circle and this swarf here, or kerf here, represents the kerf. And this green line is the lead in. So this is the lead in length to here. This is the lead in radius. And I did it a radius of 160 degrees. And I did that small little lead in and then the lead in radius. And this is obviously the radius that it's coming in. And now the blue line is standard rate of motion feed rate. And you can see our actual cut line is on this side here, and how it compensates for where its travel is against that to make up the difference. That's why the kerf width is so important. So it's going to go around here, and now we can see our reduction. This was that 1.25 inches of feed rate reduction. So the torch will start slowing down here before this corner, and then as soon as it gets to the corner, it goes automatic full speed again, that 270 inches per minute. And now right here it slows down to that 162 of optimized feed rate. Now once it gets to this corner here, it this does the same thing, slows down, speeds back up. So sorry, that phone threw me off there. Now just before this corner, it does the same thing again at this corner. It's applying that feed rate optimization. And, oh, I didn't do a finishing overlap, but you can have it cut a little beyond the starting point or the first entry point of the cut into the finished material, which helps kind of smooth out this little area here, which I probably should have added. I'm going to go re-add it right now. So you can go in here, go edit, and under passes, that is called the finishing overlap, and I'm going to just put in a micro finishing overlap of 30 seconds. All right. Oh, let's edit and reload. I might have done it bigger than a 30-second there. Let's see. Huh. Oh, weird. Why all of a sudden with the finishing overlap does it not want to work out? This is the time when all this should happen. Okay, try the smaller one. Yeah, well, it's not liking that. Let's just try a different angle, see if that helps. Isn't that weird? Okay, well, let's ditch on the finishing overlap because that's not really the theme here. That works 99% of the time, every time, typically. Okay, so now we've got some tool paths. Let's go to simulation and take a look at how that's going to run. Let's run it really quickly. Perfect. Exit simulation. Now the great part of the way we constructed this project to begin with was once we go back here to design, we can go back to edit sketch and I can change these X's to whatever I want. Ease. Let's say, and now when I go to manufacture, it's going to give me a warning. I can reload this. And now I have some new cut paths, and I can just simply go up here to NC program and make my new, I'll put in my post processor here, and its font example. I could put in all my matching post properties and post from there. Okay, and then I could go back here and just edit this a million ways and keep coming back to it. If I had some kind of plate that I was doing multiple font things in there, I could even add more letters and change it, and it's going to still work out. Here, let's do something a little more extreme than just changing the letters. Let's go into something like this stencil here, and we're going to go, I don't know, Fusion. Let's make that a smaller size. Actually, we don't have to. We can go OK, and we can actually make this a bigger size. Plate to cover it. Oh, I don't know why that did that. Have some kind of constraint that's not liking that. It doesn't want to move out equally. I'm going to do it like this instead. Move. Huh. Interesting. Some way the sketch or the sketch is attached to that. Anyways, I'm not going to deal with that right now either. Fusion's great, except sometimes it can be frustrating. There we go. Now, let's go to Finish Sketch. and we're going to go to manufacture. This gives us that warning again. I'm going to go and regenerate the program. And there we go. Gets all those pieces and run a simulation. Perfect. And we could just make new G code again. Could give it a different name so it doesn't save over. I wanted to show that one thing about the dotted lines. So if I were to go into here and explode this, let's say, but I was to hit X first, so it changed my line type to construction, and then I went explode text, you know, I am not going to be able to extrude that because it's invisible to Fusion at that point. It's just a construction line, so they don't make solid planes or solid profiles. Okay, well, hopefully that helps you out with fonts somewhat.